Okay, it's 9:40, so let's all wake up and get started. So just the announcements, I hope you see quiz 6 is out. It's due Saturday as usual. Midterm on Monday, I hope you know that that's true. So on 9 as usual. And we're gonna have 2 review sessions on Friday. So Larry's gonna do one and I'm gonna do another one. I don't know who's doing which one yet, but one of us is going to do 12 to 1:30 in PSH 150, so right across University, and same room 3:30 to 5 p.m. on Friday also. Okay. So I'm sure Dr. Copeland will mention this tomorrow, but the point of these is to come with questions or tell us questions ahead of time so that we know what to prepare and what to answer if there's anything that you're struggling with or you weren't quite sure about, all that kind of stuff. Okay? So any questions before we get started about anything? How was Form 2 Part 2? Did anyone do it? One person did it. But really, how was it? I mean, if you didn't do it, that's your choice, but unless you have any questions about it, I'm going to continue with my stuff. Okay, so what was the major thing we talked about in lecture last week? What was that?
Grammars.
Yeah, these things called grammars, right? So these things called grammars, but how did we start off? Did we just say grammars in general? English grammar, Spanish grammar? Those are the regular languages, right? So, yeah, regular grammar is what we started with, right? Okay, well, if we start with the regular grammar, well, first off, what is a grammar in this setting? So what things do I need for a grammar?
Stack variable. Stack variable.
We don't have a stack yet, but
Start.
oh, start variable. Oh, okay, so if I'm going to be having variables, I better have some set of variables, right? So we define this as a for tuple. I'll define the parts in a second. So V is a finite set of variables. And as was mentioned, we better have a start variable, right? Just like for everything that we've done so far, we better have something to start with. So S is the start variable. What else do I need? Terminals, right? Yeah. So these things are called non-terminals sometimes, so we better have terminals, right? Because I want to be able to generate strings in a certain language that the languages will be defined over sigma. So finite set of terminals. Okay. Oh, what was that fourth thing? Third here, but the one we haven't defined yet. Yeah, rules, right? So R is a finite set of rules. Okay, that seems pretty straightforward. So I get V, S, and sigma, but I don't really get what the rules mean. So what are rules? What do they do? Well, I think in general, if we want to apply a rule, I got to replace something with something else, right? So what are the things that we replace in the grammar? Yeah, we replace variables, right? So if I'm going to be replacing a variable with something else, I think we should have a left and right side to a variable. To a rule. So for a rule, I'm going to be replacing the thing on the left with the thing on the right. And was mentioned, we need a variable on the left-hand side. Well, I see regular in the name. So what do you think I want out of these things? I want to recognize the regular languages. So what string do I have to be able to generate using a regular grammar in order to get the regular languages? What one do I have to do? Epsilon, right? If I don't get that, I'm definitely not getting the regular languages. So I should allow you to get the empty string. Simple enough. What's something else that we better be able to have? Well, I think I better have a single character, right? If I can't get a single character, then I definitely can't get the regular languages. So again, I'm going to allow you to have a variable be transformed into a single term. If I don't have that, then we're toast already. Well, if we lived in this world as is, I don't think it'll be pretty interesting, right? I just have these variables that can't connect to each other. So I think I better allow you to go to another variable, replace it with another variable. So I'm going to allow you to replace it with a single other variable, keep it nice and simple. But I still think that this is not going to be very powerful, right? Because I can't generate anything more than a single character, because I'm going to only have one variable on the right that I'm going to have at any given time. So I can only replace it with the empty string or a single character. So I think I need to allow you to go to another variable, but also generate a single character, right? So therefore, if I keep going to other variables, then I keep generating more characters. So I'm going to allow you to go to to another variable, but generate a terminal at the same time. Okay. So this gets quite a bit more power. Well, how do I show that these things recognize the regular languages or generate the regular languages? How would I show that? Yeah, so if I show that I can convert a regular grammar into an NFA, then what does that show? It shows me that every regular grammar has a regular language. But that doesn't tell me that a regular language can be described by a regular grammar. It shows us one way. But what about the other way? How would I show that? That every regular language is described by a regular grammar. How would I show that? Oh, maybe I can convert an NFA into a regular grammar. Could I do that? I see one nod, so everyone agrees. So if I can convert back and forth between regular grammars and something we know recognizes the regular language, say NFAs, then I think we're good in showing that these things recognize the regular language. So let's do that. So I have a regular grammar here, so it's on a handout, and I want to make an NFA for it. So I think we need to understand what these four parts are to figure out, okay, how am I going to make an NFA for this? So what is the variable set of this grammar? Well, how did you find that out, STA? Oh, what's that? Oh, yeah, look on the left-hand side, right? So I know that variables can only appear on the on the left-hand side. And so I think that would be a good strategy. Just look at the things on the left-hand side. So S, T, and A are my variables. What about the terminals? 0, 1. How did you figure that out? Yeah, look on the, it's definitely going to be on the right-hand side. It can't be on the left, obviously. Well, how do I know to figure out what things are not terminals on the right side? What are not terminals on the right-hand side? Well, if it's a variable, it's not a terminal, right? So everything that's not S, T, or A on the right-hand side, we're totally okay. What about those vertical bar things? What are those? Are those terminals? They may be, but what is the convention? It represents or. So it's just shorthand for multiple rules. So vertical bars are not it. Oh, what about epsilon? No, because, like we did for NFAs, DFAs, epsilon's not in the input alphabet, so I don't think I should put it here. So I think 0 and 1 are going to be my set of terminals here. What is the start variable? Be very careful. Does it have to be S? No. Could it be T or A? Yeah. Just because I call, it's just a name called S. If I called this and replaced it everywhere correctly with like M or something, any one of those could be variables. Sorry, the start variable, right? So just because it's called S, it doesn't mean anything. So I think we need to choose which one's the start variable. I didn't indicate it there, right? So let's choose one of them. I'll choose S. So I'm going to choose S, but I'm perfectly capable of picking any one of the variables to be the start variable.
I have a doubt.
Yeah.
It's not like the first rule will have the start rule.
By convention, the first one at the top is, but it doesn't have to be. Because I could have written these in any order, it doesn't change anything. Right? The order doesn't dictate anything. But by convention. Any other questions? Yeah.
Is there a good convention of what you should choose as a start variable? Like choosing ASCII better, choosing T in this situation?
Like if I had, you'll laugh at me, but if I choose variables STAB, and that goes to a single terminal, I could choose B as the start variable, but it's not going to help me very much. So it depends on what language you want.
So when can it not be a start rule?
What's that?
When can it not be a start?
Every variable can be a start variable. Yep. There's no rules saying, it just has to be a member of B, that's it. That's all it is. Okay? Okay, and I think the rules are up there, so we're fine. So, now I gotta make an NFA for this, and it seems like kind of complicated, right? I have these variables, terminals, start variable, and I gotta make a set of states, transitions, final states. How in the world am I gonna do that? Well, let's see. In any derivation using a regular grammar, how many variables could I have at a given time? Well, let's see. How many do I start with? At the very beginning? One, right? Well, when I start with the start variable. Can any rule make more than one variable at a given time? No. A variable is going to only be replaced by at most one variable. So I'm going to only have 0 or 1 variables at a given time. Okay? So maybe we can represent the variables as states in the NFA. Well, if I'm going to only have at most one variable, then that means I'm in at most one state of the NFA. So I think that might be a good idea. Let's try that. I don't know if it'll work, but let's try it. And then we'll figure out what the start state is, transitions, all that stuff. And I'll worry about the variable dropping out in a second. So what should the start state be then? Yeah, I think S would be a reasonable choice, right? Because I chose that to be the start variable. It seems like it should be the start state. Okay, well, let's see. What are the final states? It seems logical to make S, right? Because that's the one where it has a rule where S drops out. But consider if I were to have it, so it'll be fine here. But if I had a rule like this, S to A, well, let's think. If I'm going to be traversing through this NFA by applying rules like this, and I get to S and I say, I'm going to apply S to A right now, what state do I go to? Well, there's no variable on this right side. So what state can I go to? I can't go to any one of these, right? Because then I would have to make those fine. So I can't do this. Or can I? Oh, that's a good suggestion. Let's make a new final state, and anytime we have a rule that makes the variable disappear, let's go to that final state. Okay, so in that final state's not going to represent any of the variables up here, so I avoid this problem that I have here. It'll work in this case, but I want this to work in general. So let's make a new final state. I'm going to call it QF. And it's dying on me. And so now we know the final state, so I think we need transitions now. So let's see. I think maybe we can apply the rules. We can look at each of the rules in turn and make a transition for each. So I see S goes to 0t. So what kind of transition do you think I should have? Right, I should go from the S state to T state on 0. So I think that's a worthwhile idea. Oh, what about that S to epsilon? Well, there's no corresponding variable on the right side, so I think I should go to that final state that we just made. And I think the thing that we should have on that transition is epsilon. Okay? So we did S rules. What about T rules? Yeah.
If we don't have the final state, can we make the S as a final state?
I could in this case, but if I had a non-empty one right here, then it's like, where can I go? I can't go to any one of those 3 states because I would have to make those final too. So it'll work in this case, but I want this to work in general. Okay? Okay, so T rules. T goes to 1A, what transition should I do? The T to A on 1, I think. So I should go from T to A on 1. T goes to 0t. Oh, what do I do there? Oh, I should self-loop, right? I go from the T state to the T state on 0. Simple enough. All right, the A rules. A to 1s, I think that's from the A state to the S state on 1. A to 1A, I think that's, again, another self-loop. And A to 0t, I think A goes back to T on 0. Cool. So the idea is, because we can only have at most one variable on the right-hand side, whenever we do have a variable on the right-hand side, just represent that as a transition between 2 states here. But if we do have the variable drop out, then that means that we're done with the computation and we have only one transition to do, either epsilon or a single character. Okay. Any questions about how we did that? Yeah.
So just a general question, is this in like the Chomsky normal form?
Good question. Is this in Chomsky normal form?
I have a separate type.
No, because I have a mixture of variables and terminals. Oh, we'll talk about that again, if there's time. Any other questions?
So QF is not the part of the variable, right?
Yeah, so QF doesn't correspond to it. It's a brand new state, yeah. So my states are going to be all the variables plus QF. Yeah. Any other questions? Okay, so now we know how to convert regular grammars into NFAs. Let's do the other thing. So I have this NFA right here, so it has nothing to do with this regular grammar. And I want to make a regular grammar for it. So how do you think I can go about doing that? Or what strategy do you think is the best one or a good one? Let's see. How many states could we possibly be in at a given time when we run the NFA?
0, 1.
Exactly 1, right? Don't be confused. NFA to DFA, I'm simulating all the possible ways I could have gone, but when I actually run the NFA by itself, I only could be in 1 state at a given time. Well, if that's true, then maybe we can employ this idea backwards, right? So maybe we can represent the transitions over here as rules over here. Okay, so let's figure that out. So what are my states of this NFA? Is it a 0, 1, 2, 3? All right. Q0, Q1, Q2, Q3. Transitions are up there, and the input alphabet's up there, so that's good. Start state, I think, is Q0. So start state is Q0. And what about the set of final states? Q0. Okay, so these are going to be important in a second. So maybe what we can do is represent our states as variables in the grammar that we made. And then all of the rules that we were going to make as the original transitions. And it's actually really nice, the notation here. So it even kind of looks like we're going from state S to state T on 0. Like even the arrow means like looks like a transition. So it's really nice that we were able to do this idea backwards. The transitions kind of look like the rules that we're going to make. So what's the start variable of the grammar do you think I'm going to have? Q0, yeah. So let's look at so this is the start variable. I'm just going to indicate it there. So now we got to figure out what the rules are corresponding to, I should arrow there. What are the rules corresponding to Q0? So I just got to look at the transitions coming out of Q0. So let's just do them in turn. Where do I go on A from Q0? Q2 only, it looks like. So I'm going to have a rule where I read it, I generate the character A, and I go over to the variable Q2. It's just employing the idea backwards. Okay, well that's number 1. What about B? 0 and 1. So I'm going to make 2 rules now. So B Q0 and B Q1. Okay. So I think we're done with Q0 now. We're not, but we'll see in a second. So Q1, where can I go on A? Where can I go on A? Back to Q0, so I have A Q0. What about B? I don't think anywhere, right? Do you think I need a rule for that? No, so the nice thing about grammars is that I'm only concerned about the things I generate. I don't have a notion of not generating here. So I'm only focused on the things that I can generate. So I only need the rules corresponding to the transitions that are there, like I did here. I only made transitions corresponding to the rules that are there. So that's good. So Q2, now we need to do those. Where do I go on A from Q2? Q1, so A Q1, and on B, I can go to 1 and 2. So I can go to Q1 or B Q2. Oh, what about that epsilon thing? Oh, just Q3. Okay, so because I don't have any label on that, I'm just going to go to, I have another rule that goes directly over to Q3. Fair enough. And then now I need to do Q3. So what rule should I have for Q3? B Q3. Yep. Okay. But this grammar as is not complete. But for the grammar as is, what language is it? Can it generate anything? No, because every single rule has a variable on the right-hand side. So I can't get a string full of terminals. So I think the language of this is empty set. That's a problem. So how can I avoid that guy?
If you just had a terminal for the video to say B instead of...
I could, but then I wouldn't generate the empty string. So here's the idea. If I can get, so Q0 is obviously the only final state. So if I can get back, I can go there somehow, then in the derivation, there's going to be a Q0 at the end, right? Because that's the state I'm currently in. Well, if I'm in the final state, could I just drop that out? If I ended up there, some string took me there, so the NFA accepts it, so I think I should be able to generate it. So how do I make Q0 just drop out? Epsilon. So I'm going to add an epsilon rule to Q0. That way, if I can ever get to Q0, I have a way of dropping it out. I may apply other things, but I have a way of dropping it out. And because I would have had some string that took me back to there, so that's the computation that took me back to Q0 and I can drop it out.
If one of the other states were final, would you add an epsilon now?
Yeah, because like say if Q2 were final, then I would add one to that, because if I can get over to Q2, then I need a way of dropping that out. Good point. So any questions about this? Okay, so let's do the next set of. So we talked about regular grammars in lecture, but what was the thing after that this led into? Context-free grammars, yeah. So let's talk about context-free grammars. Okay, well, I get the grammar part, right? I have these variables, and then I have a start variable, set of terminals, and then I'm going to be doing some kind of rule replacement, all that stuff. So what in the world is the difference between a regular grammar and a context-free grammar? Well, let's see. It seems pretty restrictive what we did with the set of rules, right? I only allowed you to have a single variable on the right-hand side and only one terminal on the right-hand side, then I had to have them in a specific order, and it seems pretty restrictive. So I think because we call these context-free, it seems like it doesn't matter what variable, for the variable that we replace, it doesn't matter what's on the left or the right. So for the variable that we're going to replace, I think we should have just a variable on the left-hand side. So the rules that we're going to have are variable goes to something. But I think we should allow you to be as general as you want with that. Keep it simple for the left-hand side, but have anything you want on the right-hand side. So let's say that you can go to some W, where W, so I think a good idea would be to have any combination of variables and terminals in any order and as many as you want. So I think we should be able to have a variable or a terminal in as many as you want in any order you want. Okay. That seems like a nice generalization, right? Makes this a lot easier, right? Instead of having just a very compact set of rules I have arbitrary text rules. Okay? So the first question is, if I remember correctly, is palindrome. So let's make a CFG for this. So prompt 3. So CFG for W in 0, 1 star. W is a, we all know what a palindrome is, right? I hope so. Okay, so the string is the same forwards and backwards. So in the characters we can have are 0 and 1. So how in the world am I going to make a CFG for this? Oh, first of all, is this language regular? No, we actually showed it in lecture. So what string should I choose if I'm going to use a pumping lemma style proof for it?
0, 1.
Yeah, so I need some combination of zeros and ones. So I can do 0 to the p, 1 to the p, 0 to the p. That's certainly a palindrome in length at least p, and you can show because first p characters are zeros. If I pump more into there, then the length of the string is going to grow. So the middle of the string, where it was in the middle of the zeros, is now going to move left. So it's going to have more ones on the right-hand side than on the left. So therefore, it can't be a palindrome. But I want to make a CFG for it. So clearly, I can't just stick to these because if I did, then it would be regular, but it's not. So how in the world am I going to do this? Let's see. Suppose we do have a palindrome. So let's say we have W1, W2, W3, whatever the string is, n minus 1, Wn. And let's say that that actually is a palindrome. Is there anything I can infer about what those characters are? Ah, yeah, if it's a palindrome, if I flip it over, then it's going to be the same string. Oh, that tells me that W1 is equal to Wn. So I can infer from this, W1 is equal to Wn. Anything else I can infer? Right, so if I look at the next character in, those are also the same. Okay, so that's good. So W2 is equal to Wn minus 1, and all the way to the rest of the string. Okay? Let's see. Well, if these characters are the same, what if, let's say, I took off that first character and I took off that last character? What is that string in the middle? Do I know anything about that string in the middle? It's a palindrome. Ah, so if I take off the same character off the beginning and the end, I should still have a palindrome left. So I think that's a recursive definition. So what would be a good base case then? Since I need a base case for this, since it's recursive. What's the smallest palindrome? Empty string is 1. I'm going to need more base cases because what if the string's length was odd? Well, if I'm going to be doing this, I take off 2 characters every time, so I'm going to end up with a single character at the end. Is that a palindrome? Yeah, so that's also a palindrome. Okay, so we have an idea of how to do this. So let's take, I'm going to only need 1 variable for this, so that's good. So the idea is, let's take off a character at the beginning, take a character off the end, and recursively call myself, because I know the middle part is a palindrome. So I need to do this for both 0 and 1. So I'm going to take off a character at the beginning, say 0. Well, I better take off the exact same character at the end. So I'm going to take off 0 at the end. And then in the middle, we just realized that this is also a palindrome. So I should go back to S. Okay? Because I'm thinking S is going to generate all the things that are palindromes, so a palindrome must exist in between this. Well, I better do the same thing for 1. Right? Because it could be any arbitrary combination of zeros and ones. Well, if I just do this, then I'm not going to generate anything. So I need base cases. So the base cases we thought were the empty string, because that's the palindrome, and all single characters, and those are 0 and 1. Okay. So all we did here was try to understand the structure of the strings in here, and then we thought maybe we can think of a way to chop some characters off, generate them in the grammar, and then recursively call myself, and then infer something about what's in the middle. And then we said, oh, the characters at the beginning and end are the same, and the middle is a palindrome. So we just recursively did that, and then we have these cases. Okay. Is that pretty simple? Everyone get that? Oh, good question. This is a good idea to bring up something. So maybe I was not that clever in doing my base cases, and I picked another base case. So let's do 0, 0, 0 as another rule. Well, this doesn't change the language, right? Because 0, 0, 0 is already a palindrome, so these 5 rules would have already did it. And the way you would have done it is s goes to 0, s 0, and then applied s to 0 with that s. So this doesn't change anything, but what happened? How many ways can I make 0, 0, 0 now? How many ways? 2 ways, right? I can apply directly 0, 0, 0, or I can go this way, obtain 0 as 0, and then this s generates 0. So I have 2 ways to make it now. We'll remember that once I get terminals, I can't generate anything else. Yeah. So I have 2 ways. All I care about is at least 2 ways. Oh, what is that called? Ambiguous. So this grammar now is ambiguous. So what does it mean to be ambiguous?
If it has more than one parse tree.
If it has, well, equivalently at least 2 parse trees, right? So what is the it there? It has at least 2 parse trees.
Grammar.
What's that?
The grammar.
The grammar has at least 2 parse trees?
Certain string.
A certain string, right? So I noticed that the string 0, 0, 0 had 2 different, well, what did I do here instead? I didn't make a parse tree. What did I do?
Derivation.
I did a derivation. Oh, what kind of derivation did I do? Did I just do any old derivation? In this grammar, there's only one type of derivation, but in general, what's it called?
Left hand.
Leftmost derivation. Oh, what's a leftmost derivation? Yeah, whatever derivation I have, I replace the variable that's the furthest left first. Okay. Well, since there's only one variable ever on the right-hand side, I can only have leftmost derivations here, so we're fine there. So let's recap. It's some string, but maybe there are 2 ways to make 0, 0, 1 in this grammar. They're not, but suppose there were. Well then, what can I say about that? Can I say anything? Do I care about strings not in the language? No. So I only care about if a string in the language has at least 2 parse trees or leftmost derivations. Okay? So it's some string in the language that has at least 2 different derivations. But let's suppose we delete that rule and you say, okay, yeah, that rule makes everything ambiguous and life's unfair now. But suppose I delete that rule. What about the grammar that is still here? Is this ambiguous? Well, let's see. How many ways can I make the empty string? Well, I have this way. Do I have any other way? No, because every other rule is going to generate at least 1 terminal. So there's only 1 way to make the empty string. Good so far. What about a single character? Well, I definitely can't apply this one. Whatever one it is, I can only apply one of those 2, right? I can't apply s to 0 or s to 1 because it can't be both 0 and 1. So I only have one of those to apply. Can I apply those for a single character string? No, because they generate 2 characters. Okay? So for empty string and 1 character, we're fine. What about a string of length at least 2? Well, I can't apply any of the, well, I could try to apply them, but it won't work. Well, is it possible for me to apply both of these? Could I apply both of these?
In what sense?
If I have a string I want to derive, could I choose either one of these rules to apply? No. Why? Because they start with different characters. So I have exactly, and I assume that the middle part can only be generated 1 way, And so therefore, the whole string can only be generated in one way. So I think this grammar is unambiguous. Okay? So what we just were able to show is that we can convert unambiguous grammar to be ambiguous, but it actually turns out you can't do the other way. But what we were able to show is that we can only generate every string in exactly one way. Okay? Any questions about that? Yeah.
So if we made it the other way where it was unambiguous, and it asked you, is this country speak ambiguous? Would it just depend on how you made it? What would you assume?
Yeah, it's the structure of the rule. So it's obvious that a language could have unambiguous and ambiguous grammars. Actually, that's a good exercise. So can I convert, so I did this one case, unambiguous to ambiguous. Could I make any unambiguous grammar to be ambiguous? Could I do any grammar? So here's an idea. So let's start with an unambiguous grammar. So I assume it's unambiguous to start with. I'm going to call it G with start variable S. Okay, so I assume it's unambiguous to start with. Add the rule, S goes to S. What did I just do? Did I change the language? No, because whatever S could generate before, it could either use the rules that already existed, or you can go through here to that rule and then just generate what you could have done before. So I don't generate anything else. So I don't change the language, but what did I do to the grammar? I made it ambiguous. And how do I, actually, something stronger. I made every string in the language have two different derivations, at least. And how do I know that? The reason I know that is that one way to generate it is just to use the rules that already existed, avoid this rule, and then another way you could have generated it is S goes to S and then apply the same thing. So I have two different derivations. So that's a way to show that you can make any unambiguous grammar to be ambiguous. Okay? Any questions about that? Okay, so let's do the next one. So this one, if I remember correctly, is 0 to the end, 1 to the 2 end, and if it's 0, and I want to make a CFG for it. Okay, well, is this language regular? Well, I don't think so. What string should I pick? 0 to the P, 1 to the 2P. Yeah, so I would pick 0 to the P, 1 to the 2P, and this proves even easier because if I just pump up more any number of zeros, then twice the number of zeros is not equal to the number of ones because I don't touch the ones. So that proves pretty easy. But I want to make a CFG for it still. So let's see. How am I going to do that? Well, the nice thing about this language is that I know what the actual strings look like. It's just zeros followed by ones. So let's look at a string with a bunch of zeros at the front, and then twice as many ones at the back. Maybe we can apply this idea of deleting some characters and then ending up with something still in the language. So how would I do that here? You were going to say?
I was going to say just add 1, 0, and then an S and 2.
Right, so well, remember I'm generating characters, so I can only delete them off of the string that I want. But the idea is exactly the same, right? If I delete a character off, a 0 off the front, and I delete 2 1s off the end, then I know that the string in the middle better be in the language, right? Because if I remove 1 0, I better remove 2 1s to stay in there. Okay, well maybe we can apply that idea. So But so now we're doing recursive things again. So what would be a base case of this? 0, 1, 1, but that would still apply to here, right? I can delete a 0 and 2, 1. So what's even an easier base case? Epsilon, right? So this grammar actually turns out to be extremely easy. So it's 1, 0 off the front, 2 1s off the end, and then the thing in the middle better be in the language. Or it's the understanding. An extremely simple grammar. It's a two-rule grammar for a non-regular language, which is actually pretty amazing. So it's just something to think about. But any questions about this? Well, let's see. Well, I have two non-regular languages, and I made simple CFGs for them. Is there some kind of connection between regular languages and context-free languages? Well, we know one direction. Is every context-free language a regular one? No, how do you know that? Yeah, we just came up with two counterexamples. I only needed one. Okay, so there are certain context-free languages which are not regular, but what about the other one? Is it the case that we have every regular language being context-free, or are there some regular languages that are not context-free? Okay, so we assert that every regular language is context-free, but how do we know that? Let's see. Can every regular language be described by a regular grammar? Yeah, how did we know that?
We convert it to a.
Yeah, we converted back and forth between NFAs, right? Okay, so every regular language has a regular grammar. Okay, well, is every regular grammar a context-free grammar? Yes, because all I'm doing is restricting the types of rules that you can have on the right-hand side. Okay, well that tells me that every regular grammar is a context-free grammar. So what does that tell me about how regular and context-free languages are? I think every regular language is context-free because for any regular language you want, can I make a context-free grammar for it? Yeah, convert it to a regular grammar, which is a context-free grammar. So every regular language is context-free for that reason. Any questions about that? I have one final thing. So, like we did ambiguous here, is this grammar ambiguous? No. No, let's see. How many ways can I make the empty string? Exactly one, so that's good. What about any string longer? How many rules could I possibly apply? 0, I can only apply this line. Better not apply that one because it's not empty. So every string in the language can only be derived one way. Thank you. Any questions about any of this? All right, let's see you next week.